So welcome to all of you. In the last lecture, we have seen some examples on the function. Okay. So we will see one more examples on the function so that the idea will be clear to you. Okay. So take a problem. Consider this is the example. Consider f from. So here what domain and codomain are very important for the one and onto function. Close interval AB. So note that. So it is what close interval AB. It is always true. This is what A less than B is always true. So no need to write actually this. Okay. Define as f of x is equal to bx plus a into 1 minus x. Show that f is a bijective. F is a bijective. Okay, so we take a solution. Given that f of x, f from 0 to 1, a less than b, defined as f of x is this is given to you. We want to prove that f is a bijective. So bijective means one and onto, means subject, injective and subjective. So first we will prove it is injective. Okay. So for injective, let f of x is equal to f of y. Okay, and we will prove x is equal to y. So this is what bx plus a into 1 minus x is equal to, so bx, so this is what is by plus a into 1 minus y. Okay, so we have to prove that this. What we will do, we will check this is what, so this is what b minus a times x plus a. This is what b minus a times y plus a. Now your a get cancelled. Okay, so then this is what b minus a into x, b minus a into y. Again b minus a is constant since b not equal to a, because what here a is strictly less than b. B minus a is not equal to 0, so you can cancel this. So this is what x is equal to y. Therefore f is injective. You may say this is what 1 1. Okay. Now second, surjective. So I will call this as a now. I will call this as a surjective. To surjective what? So let y belongs to closed interval AB. Okay. So that means we have taken y belongs to. We want to show that there exists x belongs to closed interval 0 1 such that f of x is equal to 1. That means what? Y has pre-image. So where we want to show x, where we want to show that x is closed interval 0. Okay, so we will say f of x is equal to y. Okay, so f of x is equal to y. What is f of x then? What is f of x? Bx plus a into 1 minus x times y. We will find the value of x in terms of y now. So this is what b minus a times x plus a is equal to y. So b minus a times x is equal to y minus a. So x is equal to y minus a upon b minus a. Okay, so you have to prove that. See here, this is b not equal to a. So that means what, here denominator not equal to 0. This is exists now. Only you have to prove that your x lies between 0 and 1. Okay, so now here what you have, a less than y less than b now. Right? You want here what? Y minus a. We'll write y minus a. We'll subtract this. This is what? Y minus a, b minus a. Okay, so b minus a is there. Okay, so we will divide b and a not equal, same b minus a is not, so we divide by b minus a. So this is what? 0. So 0 upon b minus a is 0. So y minus a upon b minus a, this is less than 1. Right? So here what? Closed interval, you may write this is what? Closed interval. This is right. So closed interval. So now y minus a upon b, you can say is x. So 0 less than x less than equal to 1. Okay. So I proved that. So this is what, this is well defined. No problem for this one, right? So therefore there exists x belong to closed interval 0 1. We have proved that your x is what, in the closed interval 0 1, right? So if you find this is what, f of y minus a b minus a. Now see, you get here what, you get now y. Check that this is what y. So this is what b. Okay, y minus a times b minus a. We'll check this 1 minus y minus a upon b minus a. We'll check whether it is y or not. Okay, so this is what b y minus a upon b minus a. So this is what plus a into what, b minus a minus y plus a upon b minus a. Okay, so this is what b minus a plus a into, so your a gets cancelled, okay, so this is what b minus a upon b minus a get cancelled, b minus y upon b minus a. So this is what by minus ba and minus ab get cancelled. Okay, so minus ay upon b minus a. Okay, so this is what b minus a y upon b minus a. So this is y. Okay, so that means what, y of this is equal to f of this is same as y. So that means this is your x. X is correct now, right? So what we have proved that this is not important actually. This calculation is not important. Don't do this calculation. So for your convenience, I have checked this. Okay. So there exists x belongs to 0 1 such that f of x is equal to 1. That means we have proved that every element of the codomain has a pre-image. That we have proved that. So therefore f is on 2, right? So I will call this as b. Okay, I will call this as b. So therefore what, from a and b, f is by the 2. This is also very simple example. So let f and g from R to R be defined as f of x is equal to x square and g of x is equal to twice x plus 3. Find f compose g and g compose f whether they are same. Okay, solution. F g from R to R defined by, this is definition is very important. F of x is equal to x square, g of x is equal to twice x plus 3. Now see, the domain and codomains are same. That means both the compositions are well defined here. Okay, so we find f compose g of x. So by definition, this is what, f of g of x. So what is g of x? G of x is twice x plus 3. This is what, twice x plus 3. What is f of x? F of x is x square. That means f of something is something square. So f of twice x plus 3 is same as what, then f of something is something square. Your something is here twice x plus 3. So we write this is what, twice x plus 3. No need to expand this. Okay. So we get f of f compose g. So we find g compose f now. G compose f of x. So by definition, this is what, g of f of x. What is your f of x? F of x is x square. So this is what, g of x square. What is g of x? Twice x plus 3. That means g of something is 2 times something plus 3. Your something is what? X square. So we write this is what? 2 times something means 2 into x square plus 3. Now here, see here, if you expand this is what? 4x square plus this. So here what? F compose G is not equal to G compose F. Easily. See, the formula is also not same. So the value will not be the same. Okay. So in this way you can find any composition now. So this is very important word, f of something. So this is what? Just replace x as this one in the f formula for f. F is what? X square here. What? Just replace x as twice x plus 3 everywhere. Okay. Here what? G of this. Okay. So we take another example so that you will understand this. What? Suppose this is g of x is f of x is twice x sine of, we'll write this what? Twice x square plus 3 suppose. Okay, and g of x is equal to 2x upon x plus 1 suppose, upon x plus 1, and you have to both the compositions are exist. We'll find f compose g now. F compose g of x is f of g of x. Just apply the definition. Okay, so this is what f of, just write g of x. What is your g of x is twice x plus twice x upon x plus 1, right? Now what is f of, this is f of x, this is your x now. What is f of x? Sine of twice x square plus this. What is f of something? Sine of 2 times something square plus 3. So this is what? Sine of. Okay, so 2 times, just write this something is what? Twice x upon x plus 1. Whatever this is square plus 3. No need to simplify it as this. Okay, now we'll find g of some g of f. This is what? Apply the definition. This is what? G of f of x. What is our f of x? Sine of twice x square plus 3. So this is what? G of sine of twice x square plus 3 plus 3. Right? Now this is g of something now. What is g of something? 2 times something upon something plus 1. So your something is what? Sine of twice x square plus 3. Just write this is what? 2 sine of twice x square plus 3 upon x plus 1. That means what? Sine of twice x square plus 3 plus 1. Just replace x as sine of twice x square plus 3. So this is very simple, right? So for any f and for any g, I hope that you can find any type of the composition, f compose and g compose. Here domain and codomain are same. Both the compositions are well defined. I hope that you can do all the things, right? So this is the end of first chapter. This is the end of first chapter.